doing the sign test, or introducing the sign test, I should say. We try to say what we're doing. So this is a test of the medians. Or we're testing to see if half of our points are above our hypothesized value, half are below. We ignore magnitudes. So we can have a point that's, let's say, 20 units away, above the median, but then all of our points are within 5 units below the median. That information is taken out. We lose that information. That's why we lose power of our test. So what we're going to do is take our data set, we're going to transform it to plus, minuses, and equal signs, and then what we're going to do is test our hypothesis, run a binomial test that checks if our proportions, we actually have 50 and 50, 50 above, 50 below. But again, our sign test is all about, is our median equal to some value? So here's our data set, right? Sorted it. These are the numbers that we're going to work with. And we were asking, is the median of this data set equal to 10? So what would a sign test do? We're going to move this up forward. We're going to work it out by hand. So we got our vector, 10 values. We got 4, 6, 7, 4, 6, 7, 7, 8, 10, 11. All right, that's our data. This is our raw data. First thing that the binomial test is going to do is compare each of these values to our hypothesized value. So we're setting up our null hypothesis that our median is equal to 10. And our alternate is that our median is not equal. Right, so we're going to run a two-tailed test. So 10 is our value. This 10 versus 10. So is 4 greater than or less than 10? Less. So I'm just going to go through and change all of these to plus or minuses or to 0. Right, so that's our conversion. This is, we threw out numerical information and now just have a plus or minus. All right, we have one value that's 0. Right, and that basically is it's equal. So it doesn't get counted in our test. So it's dropped out because we actually are equal to that value. So now we have 2 positives. We got 7 negatives. All right, and what we're asking now is the proportion of positive equal to the proportion of negatives? Well, how many outcomes can we possibly have from this test? Do our comparison. We exclude the 0. How many outcomes do we have? Just 2. Right? What distribution did we learn that only has 2 outcomes? Discrete distribution. What discrete distributions that we learned about? And the binomial. So at this point, we have 2 positives. We want to know what's the likelihood that we would get less than or equal to 2 positives out of 9 tries. So we had a sample size of 10, but that gets dropped out. So now we've got plus and minuses. And this is only part of it because the other one opposite end. So a p-value gives us the probability of having data as extreme or more extreme. And since it's a two-tailed test, we have to look at both sides. So our as extreme or more extreme is 2 or less positives if our median was actually. And then we also have to do the as extreme part, which kind of basically flip it away and say, well, it's 7, 8, or 9. Because we're looking at that opposite thing. Can we do this? Yeah, we could, because we're asking probability of 0 of 9, probability of 1 of 9, and the probability of 2 of 9. This covers this part of it, 2 or less. And then we can also do probability of 7 of 9, plus the probability of 8 of 9, plus the probability of 9. And this assumes that we have an equal probability of having pluses or minuses because we're assuming that our actual median is equal to 10. So if our actual median is equal to 10, we should have approximately the same number of votes. And this gives us our p-value. So could we do this by hand? Definitely. Definitely. This part is our binomial. But our sign test is the transition and then the binomial. That's how they're related. We'll learn how to use binomial test here. So how can we do it in R? Pretty easy, actually. So we've used equations. So we've converted it. So we can very easily do d binom of 0, where size is 9 and the probability is 0.5. And then we could do plus so we got d of 0, d binom of 1, d binom of 2, d binom of 7, 8, and 9. So this gives us our probability. So our p-value is 0.1796875. Which means getting 2 out of 9, is well within our possibility of randomness. So this p-value suggests that our median is equal to 10. Or at least we don't have enough evidence to reject that hypothesis. All right. So the easier way to run this test and not worry about doing the plus or minuses or figuring out the d binom function is to actually use a script. So in our Blackboard site, we now have a couple R files: standard error, bootstrap CI, and sign test. All right. So these are just regular text documents. R will open them up. All right. If you have RStudio installed, it will ask you if you want to open it up. So I've downloaded the sign test. And this is what the test is. Now this is a function. So we create a function called sign.test. And sign.test function is going to take a numeric vector. It's going to take a hypothesized median value, and it's going to take an alternative, which means, are we going to test it a two-sided test, or are we going to do a less than or greater than type of alternative test? It's set up in much the same way as a one-sample t-test. At least the formatting is much simpler. So what we do, just kind of step through what the function is going to do, is it's going to take the vector that we give it, right, and we're going to admit the missing values. We're going to strip out the missing values so it works properly. And then what we're going to do is calculate the median of our vector. This median is just to report the observed value and say, hey, this is our observed median. Just like a t-test says, this is your observed mean. And then it's going to take the hypothesized value that we give it, so we'll give it up with the median. And then we'll convert values to positive and negatives. But we're not just going to convert it and keep them. We're actually going to convert to the positives and count them up, because we need to know how many of these we actually have. And we're going to accomplish it using these. So the positive values, it runs a logical test and asks each value, is the vector value, so is the value in the vector greater than our hypothesized value? And it's going to return either a true or a false. If it's true, it's a 1. If it's false, it's a 0. So we're going to convert our numbers to 1s and 0s, and when we add them up, we get how many of our values are actually greater than that hypothesized value. We're going to do the same with the values that are below our hypothesized value. Note in these, we don't have an equal sign. We're going to ignore all the values that equal our hypothesized value. And then what we'll do is take a total number, the negative plus our positive values to get our total. That's going to be our out of number that gets passed on to our binomial test. And then our alternative and obs, this basically is figuring out, are we going to do a greater than test or a less than test or a two-sided test? That's all that this is working on, because that gets passed onto our binomial test. So we're going to pass how many positive values, actually the minimum of those. That'll be the positive because of how I've had it set up. And it's going to save the p-value, and then it's going to output a bunch of this stuff. So what we're going to have is, this is our function. We open it up. We can run it just like this, but since we're going to work with a markdown document, I'm going to highlight it all and copy it. And then when I go back to our markdown document, I have that functions section, right? So this is the standard error function. And then I'm going to write the sign test function. And here I'm going to paste it. So when I run this, it generates a new function. Just like how we did our function for the standard error, the STERR. Just copying and pasting it to get into here. And why did I give it a second line? Let's get that fixed. Oh, I know why. It's all on one line. Let me do that. Hit enter. That looks better. But anyways, we have our function. So now that we have it available, I'm going to go all the way down to the bottom. And we're going to talk about this just to use a function. The sign.test function was created to run the sign test on a numeric vector. All right, so the function itself is sign.test. It's going to take a value x, a numeric vector x. It's going to take hypothesized median and then alternative equals. And our default is two.sided. That's our default. So with this function, our x will be the numeric vector. Our median is the hypothesized median value. And then alternative this tells us that we are doing a two-tailed test. All right, so for that, our alternate hypothesis is that our median is not equal to the hypothesized value. And then we've got these other ones where alternative equals less. So our median now we're saying is less than the hypothesized value. And if we use alternative equals greater, then we're saying that our hypothesized or our median is greater than that hypothesized value. And both of these are one-tailed tests. So this is set up very much the same as a t.test function when we do our one sample t.test. So for our vector, we called it dat1. So I'll do sign.test, dat1, the median equals 10, and alternative is 2.sided. So there's our example, dat.1. When I run this, I get this nice output. So it tells us the data set that we're using. This is dat1. The median of our actual vector is 8.5, which you might say, wow, that's kind of crazy because we only had, what, 2 values greater than the hypothesized value, right? We're comparing 8.5 to 10, and it's saying, well, if we actually were 10, there's no big surprise that we would only get two values. Two-sided alternative hypothesis, p-value is 0.1797. Is that the same value that we had when we did it this long way? Yes, it is. Exact same value. So the sign test, we actually create this function so that we can run it. And we can run it if we have non-normal data. But we have to recognize that we're comparing medians, we're not comparing means. Conceptually, what our sign test is doing is converting our values to plus or minuses by comparing it to a hypothesized value. And then if our median is equal to that hypothesized value, then we expect about half of our positives, or half of our values to be greater than the hypothesized value and about half to be below. But again, we allow for variation. We allow for randomness. And that's why we run our statistical tests. How likely is it that we would actually get data as extreme or more extreme just by chance alone, if the null hypothesis was true, if our median actually was 10? All right. So this is everything that I have here that's in that script. This is if we were doing it long way. You have the sign.test. All right. We have the sign.test. So that is what we're going to use. So we've got our pond 1. All right. So we're going to practice with pond 1, and then I'll let you guys do pond 2, pond 3, and pond 4. All right, so is the median length of pond 1 equal to, I think we're using the same values, 24.5. All right, so initially we asked if the mean was equal to 24.5. But since we're going to do a sign test, it now becomes, is the median equal to 24.5? All right, so our null hypothesis is that median is equal to 24.5. Our alternate is that our median is not equal to 24.5. We will It doesn't really matter if we assume that we violate normality. We just want to run a sign test. That's what we're interested in running. So I'm going to run sign.test. We're going to give it our mosquito fish $pond1. That's our vector. We're going to specify our median, what we're testing against. And alternative is two-dot-sided. So I wrote it right in the code. The function's already loaded. I can see it under functions. When I run it, it is. That up. I won't get on one line. There it is. Look at this. So again, output's pretty useful. It tells me what tests I ran. It tells me the data set that we used, our observed median, our hypothesized median, p-value, or if we're a two-sided or a one-sided test. The only thing I didn't have it do is write our conclusion for us. So we have this. What's our write-up? Our write-up is including everything that we need to include in a write-up. So conclusion or interpretation. Median length is not equal to 24.5. What test did we run? We ran a sign test. Do we have a test statistic? No. Do we have a degrees of freedom? No. The only thing we have is a p-value. So why don't we have a test statistic? Why don't we have a degrees of freedom? Well, this part of test, when we ran a binomial test, this was actually a form of an exact test. We know that our pluses or minus is a binomial variable. It's a dichotomous variable. So we can use our known probability theory to calculate those exact probabilities. So we don't have a test statistic, and we don't need degrees of freedom because we're not using a table to find that information. We're calculating our exact probabilities. So for a sign test, we only need conclusion, interpretation, the name of the test, and our p-value. And that will work. So I'm going to go back up here where we introduced our sign test. And we're going to have our write-up requirements. All right, so we need our conclusion or interpretation. We need our test, and we need our p-value. Those are the three requirements for a write-up for a sign test. So now, to run through these. So we're going to use our sign test to address pond 2, pond 3, and pond 4. Pond 2, we're going to ask, is the median equal to 25.15? Pond 3 is a median smaller than 25.05, and pond 4 is a median greater than 23.75. So go ahead and have them, run them, have a write-up for it, and then we will check and compare our answers. pond 2, oops, it's median length of pond 2 equal to 25.15. So our null hypothesis is that it is equal to 25.15. Our alternate is that it's not, so it's a two-sided test. So we use sign.test, mosquito fish $sign pond 2. Mosquito fish is what I read my data set in as. All right, we specify our median. It's a two-sided test. So we look at this. We are looking at our p-value. That's what we're looking at. So if the p-value is greater than 0.05, then we fail to reject our null hypothesis and conclude that our median is equal to 25.15. Yeah, it's close, but it's still greater than 0.05. We've got more than a 7% chance of actually obtaining these data just by random chance if the true median is 25.15. Pond 3, we're asking if the median length is smaller than 25.05. So median, our null hypothesis is that they're equal. The alternate is that our median is less than that 25.05. So I use the sign.test, and this time I specify alternative equal less. And I get a p-value that is 0.31. Again, this value is greater than 0.05. So we fail to reject this. And thus conclude that our median is equal to 25.05. Now, going back to the question we asked, is it smaller? No, it's not smaller. It's actually equal to 25.05. So that's where my conclusion. No, median length is not smaller than 25.05.
I'm getting this one answered, but when do you how do you know what to write from the because I just keep putting less than or greater than 0.05.
So this goes back to our p-value rounding. So let's roll it. Let's get those added. Things to report and write up p-value. We'll do this. P-value rounding rules. So if p-value is greater than 0.01, then round to 0.01. All right, so if it's greater than 0.01, we're just going to round to that 0.01. So anything greater than that. If we are between 0.001 and 0.01, then round to 0.001. So kind of between this. If we've got 3 decimal places, but we're not quite at 0.01, we're going to go to 3 decimal places. If our p-value is less than, or is greater than 0.0001, but less than that 0.001, then round to 0.001. So if we're above that 4 decimal place mark, but not quite up to the 3 decimal place mark, we're going to round to 4 decimal places. And then lastly, if our p-value is less than 0.0001, then we write p is less than 0.0001. So if we're below that 4 decimal mark, we just say p-value is less than 0.000 and leave it at that. And we'll see it. We'll get p-values that are like 2.26 e to the negative 26 or something like that. It's something the smallest that the computer can calculate. And we just default to this. P is less than that. Now, as far as writing equals versus less than, that's going to kind of be up to you. I just feel like if a p-value is if a p-value, we'll go down here. We've got pond 1, pond 2, pond 3. If this p-value was 0.314, right, it would round down to 0.31. If it was 0.314, 6, it would round up to 0.32, like this one, 0.0768. That rounds up to 0.08. I just feel like it's better, instead of saying P is equal to 0.08, I could just be a little bit more specific and say, well, it's not quite at 0.08, it's less than that. Does it matter? Probably not. It matters when we are right around the 0.05 though. That's where like a 0.049 would round up to 0.05. But I think it's important to say that it's less than that. All right. And then upon 4 greater, we give the alternate hypothesis in our question. So we get a 0.02. So median length is greater. So again, p-values less than 0.05. It's less than 0.05. Likelihood that we get these data is pretty small if our median is actually equal to 23.75. So we reject our null hypothesis and conclude that our alternate is the correct. And our alternate here is that our median is greater than 23.75. All right. So what we'll do is we'll review this on Wednesday. Get a little review. I do have, were any of the conclusions from the sign test different? No, I think they were all the same. And it usually will be. We didn't have any t-tests that put us right around 0.05. And right around 0.05, I'm talking 0.048 to like 0.052. If we were at like 0.048, there's a chance that the t-test gives us a significant p-value, but the sign test does not, and it's because our sign test doesn't have as much power. But for us, they were all the same. All right? So we'll review this on Wednesday and then move on to the bootstrap confidence. All right. So if you want to take about 5 minutes, get ready for this exam. I do have, I've got the equation sheet, if you like it. I've got our normal tables, which you'll probably want to use. And I have t-tables. But if you have your own tables printed out, you are free to use those. You probably want scrap piece of paper. And if you need a calculator to use, I have a couple. Should be live. Our quizzes or exams, theoretical. You'll need scratch paper, calculator, copies of the normal table and t-table. Can't move back. Means one question after the other. All right. You have a total of 40 questions on the exam. You'll see some of these questions are what I would consider pretty simple, pretty quick, pretty basic. You do have a couple where you will do some calculations. All right, and out of 40 questions, that's 40 points. I'll scale it out of 50 points. Once you start, you have 60 minutes. If you have a question, call me over.